Hello Linux lovers, my name's Wimpy, welcome to my world. And Yannick, you're wrong, and hello Paul. So, welcome one, welcome all. If you're watching this on YouTube after the fact, then you can, let's start that again. If you're watching this on YouTube after the fact, this was originally streamed live on twitch.tv/Wimpy's World. So if you want to join in interactively with the rest of the community, then head over to Twitch/Wimpy's World and give us a follow. Good morning. How's everyone doing? This is going to be a continuation of the last stream with a couple of extra bits thrown in. So this is 3 projects to make some new gaming devices, one of which is going to be a SteamOS console. So I'm going to look at like the initial hardware selection I've made for that out of my spare parts basically. And interestingly, I've decided to go with the Ryzen 4750G APU as the CPU. I'll explain why in a bit. And today we're going to look at how we overclock that APU and then undervolt it. And I'll explain why we want to be able to do both of those things in this console. So welcome, hello, good morning, good morning. There's loads of you here. How's everyone doing? It's a little bit cooler today. The last stream ended a bit abruptly. We'll get into that first. So yeah, the last stream just ended. This machine thermal shutdown. It was the second hottest day on record. So I've put some countermeasures in place since then. I've updated the BIOS, I've changed the fan curve in the PC, I've undervolted the CPU, I'm streaming at 30 frames a second instead of 60 frames a second, and I've put the CPU in power save mode to try and keep it as low as possible. So we'll see if that keeps everything in the right spot and prevents everything from halting. And I'm a bit late starting because well, Bluetooth was messing around with my volume levels and I couldn't hear anything and it was very confusing. Turns out I just needed to reset the audio transmitter. So hello, welcome back everyone. How is everyone? So Paul liked that intro music. Yeah, that was a little bit of indie pop, and that's the current theme that we'll have playing in the background today. I'm very close to implementing a viewer jukebox so that you'll be able to use channel points to actually choose like your genre of music and maybe even skip tracks and what have you. There's one little issue I need to overcome with that, but it's very close to working. Broken Rabbit says they felt like they needed a thermal shutdown yesterday. Yeah, it was hot here yesterday for sure. I mean, it's a bit better today, but it's still warm. We need a really good thunderstorm, I think, to clear the air. So how is everyone? Yeah, okay. Let's get into it. I can see some of you talking about debget. Yannick is casting aspersions that it doesn't work. So I tell you what, let's just go and prove Yannick wrong, and then we can all move on with our lives. So I'm running debget version. So this is the new release that just went out this morning, 0.32. I can do all of the things. I installed stuff, I updated stuff. It's all doing the right thing here. So I don't know what your difficulties are, Yannick, but I'm going to need more to go on. So telling me it doesn't work with no context, you know better than that. So I look forward to some updates. And Diogo, well, welcome, good morning. Yeah, no, you. Well, okay. Let's just do debget install copy queue. I don't know what copy queue is. The download URL for copy queue is empty. There we go. Is copy queue supposed to be in there? Debget list. In fact, let's do debget search copy. I don't know if there's a thing in there. So there we go. It's not working because the download URL is inaccurate for some reason. So a different bug. But copy queue is installed from a PPA. Okay, well, have a little look. Oh, okay. All right. Okay. So maybe I can see why that may be working. We'll look into that maybe tomorrow or later or something, but not right now. So let's get back to this. So let's start with a little bit of show and tell because a new thing turned up. So let's start with that. And that was the Razpad. So this is one of the devices I want to be working with Retro Home. So if we put the overhead view in, here it is. This is the device. So a wedge shaped, quite a chunky device. And you can see here it exposes some ports on the side. So Ethernet, 3 USB ports, HDMI, Courage port and power. And then on this side you've got some, well, the memory card, and these are display brightness rockers and what have you. So I've done half a job of putting this together, but not screwed it together. So hopefully he says I should be able to separate it again. And I can show you what it looks like on the inside. So far, I'm quite impressed with this little device because it's similar. No, it's not similar. It puts me in mind of the Desk Pi in that it's very precisely put together. So all of this was pre-constructed except for the Raspberry Pi and the cables. So this is the daughter board that it comes with. This they call the button board, which is where the brightness and what have you work. It provided all the heat sinks and the cables and everything you need to put this together. You don't have to do anything with the battery or this board here. You do have to install that little exhaust fan, which then has a header over here. So I haven't put that together yet. Everything it gives you more heat sinks than you need, it gives you more screws than you need, so it all works. And right here in the corner on the GPIOs there's a tiny little device sat over the first 6 pins, and that's an accelerometer. So I haven't looked into this yet, but I'm guessing that will enable, you know, the detection of screen orientation. So that will be interesting to get working. So that's all I've done. I haven't powered it on. I haven't charged it yet. I literally just screwed down the Pi and plugged the cables in. What I think this could also be interesting for is it's quite a wedge shape, but if I could just line the thing up. It's always easier when you don't have to think about what you're doing. There we go. So what I quite like about this is because of this fat edge here, it actually stands like so. So I'm thinking with the accelerometer installed, this will actually be better than I anticipated for a portable gaming system, because you'll be able to stand it up on a table, and this will be the screen and the sound with wireless controllers. I think this is going to work out better than I had hoped. So that's as far as I've got with that. We will cover this soon. The next step for me will be to go and research what software needs to go on in order to fully support the device. So that's arrived. So so Takov asks, is there space for a smaller extra daughter board in that case? There is space to spare for sure. So one of the things I was wondering about, I don't even know if this will work, but it's something I'm going to investigate on the Pi. There is only one USB 3 port that connects to the daughter board. So there's a USB 3 port and 2 USB 2 ports on the Pi here doing nothing. So I was thinking it might be possible to put like a Windows 10 wireless Xbox dongle in here, because I really want to use this as a gaming device. And then you'd have permanently installed inside of this the dongle to pair your controllers with. So that was one thought. But yeah, there's space. There is plenty of space here. That is a deep case, and there's definitely room to put stuff in here. Not a huge amount of room, but a reasonable amount of room. So yeah. But then of course you've got these three here as well, which pass through. And I'm interested to see how the screen works, because it's got both the HDMIs on the Pi 4 populated. I'm guessing one of those is to power this screen, but then there's this full HDMI on the side, so I wonder if it's going to do a separate like output, so you can effectively, I wonder if it mirrors by default. So things to learn and discover, but an interesting bit of kit nonetheless. Yeah, and Diogo, you could put a wireless keyboard dongle in there, or one of those ones that's a combo adapter. I do have one at home which is a keyboard and mouse combo that uses a single dongle. So again, you know, those sorts of options would be interesting. But I do have a very, very small keyboard. It was originally designed, I think, to go on the on a controller of like a PlayStation 3, you know, for text input in games, and I separated it from its housing, so it's a very, very small like QWERTY keyboard, and I've got that on a USB cable, and I thought that might be like the thing to it's like the thing I put in the backpack with these small devices in case you need just simple keyboard to do some things. I can't power it on KingyJet, I haven't charged it up. So literally it's been plugged together, so we'll get to powering it on another day. Right then. So let's look at something else that I am very pleased to have discovered. I talked about, you know, I'm going to make this SteamOS console, and I now have three, let's call them graphics options, because I'm going to use the 4750 APU. That obviously is a GPU in air quotes, so that's one thing that can render games. I have the RX 580, which will absolutely fit in the Node 202 case. It's a slimline case I'm going to be building this in. But having tested that briefly, it produces quite the heat. So although that's a smaller card, I'm not sure that's the way I want to go. Anyway, I have this RX 5700 XT, and I discovered something awesome about this. So this was a 2.7 slot card, but I have discovered after taking the shroud off, doing what's called a deshroud, that this now is a 2-slot form factor. So I'm intending to use this as a deshrouded GPU. So this will be upside down. This will plug into the case like so. So it'll be a slimline case, and it will plug in here. This will be at the top of the case, pretty much touching the top lid. This will be facing down into a fan bay, and I think, having removed the shroud, I'll be able to put two large 25mm case fans underneath this and use big case fans to cool the GPU. So I have a whole bunch of 120mm case fans at home that I can experiment with. But this is absolutely perfect for doing a deshroud mod, because it's got no lips or screw points or anything. It's a completely flat surface, and this is the plastic shroud that I removed. So you got your 3 fan headers for the fans here, and an RGB header for a logo that illuminates there. So by removing that, it shaves off quite a lot of thickness, and so I think I'll be able to use this GPU, which will be terrific because it will take the performance to a whole new level, and hopefully I can cool it, but we'll figure that out another day. I need the case to arrive before I can start taking measurements and figure that out. But I think this is going to work. So King Egypt saying, what's the big fanless GPU? Yeah, so this is it. It's the 5700 XT, and I don't have any with me. I don't think, no. But the case that it's going to go in supports two 120mm case fans that are 25mm deep. And if it doesn't quite work with the fat ones, then I've got some slimline ones, or at least one anyway. So yeah, we'll be using case fans on top of the fin stack to cool the GPU. And that will require some testing, because there's three potential options on how to configure that. Either static pressure fans that blow onto the fin stack, or pull off the air and exhaust it out of the case, or maybe even one in, one out. Because it is a very tight fit, the case. It's going to be a tight fit. And I think airflow is going to be critical. So we'll figure that out. Yes, it turns out I completely lucked out. I didn't realize it, but this is the Gigabyte Gaming OC 5700 XT. And it turns out, after looking at some reviews, this is very well put together in terms of its cooling potential and performance. Hello, Pixel Perfect. Welcome to the stream. Make a blower. So interesting you should say that, because I have considered it, because I also have in my box of parts, I have two of these. I only have one with me. Now these are kind of interesting. That's just a back plate, we don't need to look at that. But I have two of these, and these are this is a cooling plate here for an AM4, and this is a fan, and you can see here this has got an exhaust. So this is actually designed for 1U servers with AM4 processors, and it's designed to cool 95 watt parts. And the idea is you put some ducting on here and you take the air away. Now I actually got this one, I have another one just like it at home for a different project, for another small device that I'm working, or two small devices I'm working on. Thank you, welcome to the stream. And I have a 3D printed duct for the case that these go in. But yes, it is not beyond the wit of man to mount these on there. Now I think the clearance might be an issue, but potentially could make double blower style coolers to go on there. So all sorts of options. But I think the static pressure fans that I've got, because I've got some spare from an old build that I'm not using at the moment, so I think those should be able to push enough air around that they'll do the job. But yeah, and also the other reason I have this is I was potentially thinking of using it as a cooler on here, because I was thinking about using a different CPU and I needed a more capable cooler, but I've decided to go with the 4750, and we'll get into the whys and wherefores of that now, in fact. So I'm quite looking forward to having a tinker with that. There's the back plate for the cooler. Right then, if I'm not keeping up, I do apologise. Yeah, so McPhail makes a good point here. This bit's open to interpretation. But fans are like USB devices, always better inserted the other way around. And certainly on GPUs that are going to be near a case exhaust point, it seems that the best option is to pull the air and exhaust it out of the case, rather than to pump air down and push air into the fin stack. but I will have to test that because the variations in different case design are very different. Thanks for the sub, by the way, JH. I think that's good enough there. So, Big Smiler, I think you're asking here about the cooler I was just showing you. Is that one of those painfully loud designs? Yes, sounds like a rocket ship taking off. But that top fan is also removable. So, but with the ducting, it's not so bad. So it's for a different project, not for one of these ones that I'm working on here. But maybe one day I'll bring them in. It's basically reproduction Commodore 64 cases with mini ITX system inside it. That's what it's for. Yeah, and yeah, in fact, you mentioned there, using 3D printed ducting for the other project. There is a company locally that has designed and fabricates the ducting for these reproduction Commodore cases. So I don't have a 3D printer of my own. I took a decision some years ago that I know enough people locally with 3D printers or who offer 3D printing services. It would be cheaper just to pay somebody to 3D print the odd thing that I need printed from time to time rather than invest in a printer of my own. Hello Plain Text Nerds, welcome back. How are you doing? Thanks for stopping by. So now we're going to get on to this here. So this is the machine I'm going to use to build the console. I've just got it on my test bench at the moment. It's got a small form factor 750 watt PSU underneath. Some changes I've made is I've now built this on top of a B550 mini ITX case motherboard. The reason I've done that is for two reasons. The Node 202 that I'm going to be building in is PCI 3 only. The Ryzen doesn't support PCI 4, Gen 4 rather. So just to keep things simple, it's going to be a Gen 3 build only. And the other advantage is the M.2 on this B550 board is a solid state cooler, whereas the X570 board, which is almost identical in every way other than being X570, has active cooling on the M.2s, which is another potential source of noise. So I decided to change things out for that. And then I've put the Ryzen 4750G APU in, and this is a Noctua something. It's one of these, in fact. So it's a low profile NHL9A for AM4, and this kind of is how I decided to use this APU. My original plan was to use a 5900X that I have spare, but that will overwhelm this cooler. And one of the objectives of this build is to only use parts that I have already available. So I happened to have this, so I'm using it. And this is more than capable of keeping that APU cool. So I think that's kind of what I've done. I've just rebuilt with the B550. I've installed a Linux distro on it, and we'll start it up and take a look at a few bits. So I think we'll just boot it into the OS, and then we'll go about looking at how it was overclocked, and then how it was undervolted and what the impact of doing that is, or at least to some extent. So I think if we switch to there, I've got my my detonator switch here to turn it on. So we'll just press that button, and then we'll start spamming the delete key on a second keyboard that I have over here, and hopefully we'll yes, King Egypt. I know it sounds ridiculous. It's like PC World at my place. I have a spare 5900X. In fact, I have a bunch of spare spare CPUs. It's kind of helpful when I want to experiment with something, just be able to go in and pick things off and put a system together. Not a scalper, absolutely not a scalper. Right then, this is the BIOS of the board here, and we'll just go through some of the changes that I made. So the first thing is, when it comes to overclocking these APUs, I wouldn't say I am an experienced overclocker. I know just enough to be dangerous, so heed my tips and advice with extreme caution. One of the things I have learned is overclocking the CPU, there's really not much headroom, and you're just going to be using more power, generating more heat, running into instability far more quickly. So I've deliberately stayed away from overclocking the CPU itself. So what we're going to do is we're going to exclusively look at two areas for overclocking this APU. First of all, it's the graphics clock, so the CUs, the compute units themselves. And this is a fairly decent overclock, up to 2.2 gigahertz. I forget what the base clock is, but it's 1000 and something. I forget exactly. But you can't, I've not seen anyone successfully go over 2300, and I can get this to go to 2275, but I feel like that's always a bit close to the edge. So what I do is I figure out what the absolute stable limit is, and then I always back off from that little bit. So this is where I get my 2250. And then I've been able to then undervolt that graphics core quite considerably. So I think this was running at 1.2 volts. So that's quite the undervolt. And this is keeping the same performance and frequencies, but at a lower voltage. Lower voltage translates to less heat, and therefore you don't need as much cooling in order to keep the thing under control, which means less noise. So, you know, that's sort of the extent of the GPU overclock, except for one very important factor, and that's that these APUs use system RAM as, or rather they take a chunk of system RAM that they use as their video RAM, in air quotes, a bit like how the Raspberry Pi, or at least how the Raspberry Pi 2 and 3 did it. So what we do therefore is overclock the memory, and the more we can overclock the memory, the more significant the performance improvements are for anything that uses the GPU on the silicon. And you can really make some big improvements here, and we'll look at what those improvements look like in just a moment. Now, it turns out I've been quite fortunate. I have it wasn't meant to be a particularly special kit, but this is a HyperX pair. It is 64 gig, so not intended to be fast, but I seem to have got lucky because the XMP profile on this will go to 3466 CAS timing 17. The CAS timing has an impact on the memory latency, and I'm actually able to drive that up to 3800. So this is effectively operating this as double data rate, 1900 mega transfers a second. So we get DDR 3800. It can go slightly higher, and again I got it up to 3900, but it was a little bit on the edge, so I've backed it off. And again, the more that you clock this memory up, the more heat these sticks generate, and you have to deal with that in some way, and I've got some ideas about that. So this is going to run hotter, but this is quite a considerable overclock, and it also turns out that the timings on this are quite tight as well, so it's quite tuned memory. Hello Arif, how you doing? Thanks for stopping by. So and then here we then undervolt the CPU V core, and again this is fewer volts, it's less power, it's less heat, so hopefully less noise as well. So I'm trying to tune this as best as I can now, so that when I start building in the case, we have like the best that we can achieve in terms of heat and power and what have you. So I see there's been a few questions, so let's just, oh, not that mouse, I can't use that mouse to get up here. So let's take a look here. So McPhail says, so you're not limiting to absolute multipliers on the GPU clock, the way that old AMD APUs worked. Correct. I'm not changing the multiplier, I'm just changing the frequency of the GPU clock. And what's important here is the way that Ryzen works, or at least this is Zen 2, is that you've got this F clock frequency, which should be half of the memory multiplier. Now it should deduce that by this option here, but I'm actually setting it manually and only moving in increments where I can do precisely half the frequency for the F clock. So I think that's understood that. And then Plain Text Nerd says, I've just upgraded both PCs. My main workstation now has an additional 32 gigs of RAM and 2 terabytes of NVMe storage. Steam Machine has an RX 6500 and 3800 XT and an additional 480 gig NVMe. Yeah, nice upgrades indeed. So this is a project that I'm working on here, which I talked about in the last stream on Monday. The idea is that I was given my option to buy a Steam Deck over the weekend, which I declined to proceed with, and instead decided to use the money to make 3 gaming devices of my own. The rationale being I enjoy making stuff more than I enjoy playing games, so I'm going to use the money to make some new things, and then other people can use them to play games. But this will become an actual games console that goes under the telly in the front room and will just be instead of an Xbox or a PlayStation. And because we do Linuxy stuff here, it's going to be running SteamOS. So there's a project called Holo ISO, which is a build of SteamOS 3 that you can install on a PC. So hopefully within the next week and a half, this will be a fully finished in a neat under the telly case with wireless controllers and SteamOS and all the rest of it. My daughter plays PC games. It's all she's played because that's all she's had access to. So instead of buying a console, I thought we'll keep with the PC gaming stuff. We'll just make it more accessible rather than having to go to my office at home to play games, which isn't always convenient for me. So that's like most of what you can do in terms of like fiddling with memory frequencies and GPU clocks, but there's a couple of other things you can do, and I bet I can't remember where all of these are. So we'll just take a look somewhere in here. Here we go. This exists elsewhere as well. You'll see that TSME I have disabled. I have made this choice, and you'll also see, rather unhelpfully, it says no help string at the bottom of the screen. Can I bring the down here? No help string. So TSME, massive oversimplification, is the memory encryption that AMD Ryzen Pro APUs can do. I have turned that off it makes a very slight improvement to the performance of the APU. Now, you can actually poke around in some of those settings in a bit more detail. I think is it MBIO? One of these. No. Somewhere in here. Here it is, security. This option exists again here. And then there's also data scrambling, which I've also disabled. So again, these are like advanced options for the Pro line of APUs. You turn that off and you buy back a little bit of performance. I don't need these security features. This is going to be a games console, you know, in the front room. And there's a few other little gems hidden around in here that are similar that I've tuned, and I can't remember all of them, but most of them are just to do with the appropriate configuration of the device rather than performance seeking. But I thought I'd point that one out because that one's kind of important. So you can see over here the voltages that it actually runs at. It uses an offset system. So down here you can see that I've actually fixed the memory voltage to 1.350. You always get a 30 milliamp offset for some reason. It isn't documented. I don't know why. But curiously, if I set this any lower than this number here, then the system won't post, for example. It's a dead board. So this is the safe limit. If you set this to auto, the memory was almost at 1.4 volts, which is quite high. So this again is quite a significant undervolt, and that just helps the memory chip stay cool when you're, you know, running games and stuff like that. So McPhail says, on the subject of security features, does mitigations off make a big performance difference on recent kernels? It does. In fact, let me show you something. It makes more of a difference on Intel CPUs than it does on AMD CPUs or APUs. But as you asked the question, let me show you a script I have on my machine. There it is. Went right by it. So let's just go over here. I'll just move this keyboard to one side. I have a script in hardware, and it is called Make Linux Fast Again. And what it actually does is it uses the website makelinuxfastagain.com. So let's go there for hang on a minute, what am I doing? Here we go. Let's go there and show you what it is. So what this does is it basically gives you a big long string that turns off all of the mitigations for things like Spectre and Meltdown that can have a significant impact on the performance of particular workloads. So if you add these kernel parameters to your boot environment, then it will turn those mitigations off. Now, I'm going to caveat this by saying you do this at your own risk. But if you've got what is effectively a single person workstation and you are not exposing any services to the internet, then you might want to consider turning this on. And for what it's worth, I do. Now, if I just go back to my little script here, what this does is this is a script that's targeted at Ubuntu. It has wrappers around it. We check the current mitigation status, and then what we do is we drag those parameters in by wgetting that string off, scraping that off the website, and then we drop that in as a configuration into etc default grub.d and then update grub. So that's a way to easily add additional kernel parameters to your system without actually changing like the default packaged grub configuration. So that's how I do that. Yes, it is, Esme. These are the Spectre and Meltdown mitigations. It's ostensibly, that's what they are. Now, I have applied these mitigations and benchmarked stuff, and I have seen no significant difference in game performance by turning these mitigations off. And that's because, and I'm guessing here, I don't think gaming as a workload works the CPUs hard enough to actually see, and the execution paths in the kernel that really hurts gaming performance. So I have done benchmarks. I haven't been able to measure anything other than run-to-run variance. So there's that. When you look at database workloads, you can measure the difference. Gosh, I can't quite... Medema, is that how I pronounce that? Medema asks, would this work on Ubuntu derivatives like Pop OS? Providing they have the same mechanisms to update the kernel parameters that you boot from, then yes, it would work. Whatever way you can coerce your kernel to boot with those parameters, it will work. So go to makelinuxfastagain.com and yeah, use those options if you want to. I'll be interested to hear from people that do benchmark before and afterwards. Welcome to the stream. Thanks for stopping by. So there you go, McPhail. There's that. But on AMD GPUs, APUs, this has doesn't have the same impact it does on Intel, because the impact was not so great on AMD with Spectre and Meltdown. Right, where was I? I was on a completely different screen, wasn't I? Let's do this. So I think I've gone through, like, we've done a bunch of stuff, but mostly it's to do with memory overclocking. So I think what we'll do is we'll now look at, like, well, it's not like overclocking on a PC. Sorry, let's say that again. It's not like overclocking on Windows, where quite often you can run things like Ryzen Master and other overclocking tools whilst the system is running and actually dial things in at runtime. This is a bit more tedious. It's like old school overclocking. Make some changes in the BIOS, boot the system. Did it even boot? If it does, now go and run your suite of tools to like measure the impact. So let's go and look at the tools that I use to verify if an overclock is stable or not. So we'll just let this system boot up. King Egypt, yeah, that sounds about right actually. King Egypt was saying that they remember taking a 20% hit on their database servers with the mitigations for Spectre and Meltdown. Yeah, it could have been in that order. It could have been less than that. I remember when I worked at Canonical, one of the other mitigations was to turn off, I think it was hyperthreading. So a lot of our internal clusters lost a massive amount of capacity. A noob of the Linux says, did you know that having DMZ on your network has been done since... I know about DMZ, so I'm not quite sure what the question is. Did you know having a DMZ on your network has been done since the early 90s? And do you know how dangerous it is? Yes, because I used to be a vulnerability analyst. I know exactly what these things are. But yeah, I don't have one of those on my network at home, as it happens. Right then. Right then. But it doesn't even have to be a DMZ. It could just be port forwarding, right? Let some people, port forward to web apps that they're running on their home machine, for example. So it doesn't even have to be a full, DMZ, which could be a subnet of devices. Right then, so this is Ubuntu Mate running on this box at the moment. I haven't got to the point where we're putting Holo ISO on yet. I've added a couple of applets to the panel here, and I'm just going to go back to this comment here. Luke says, this is why tail scale is great. Indeed, I use tail scale to connect this machine to the home network and vice versa, so that I never have to expose any of those ports to the public internet. It's terrific, and it's also why you can deb-get install Tailscale. And in fact, I only started using it recently. I was using auto SSH tunnels, but it was somebody that requested Tailscale that get added to deb-get that I found out about it, and as soon as I read it I was like, oh my gosh, I want this in my life. So added it to deb-get, and I've been using it for a couple of 3 months now, and I think it's fantastic. Yeah, you can deb-get it, and if it's already installed, deb-get will update it for you. Right then, so this is the first thing that I add to the thing here. One, to see the CPU frequency and potentially control the governor if I want to. One, to look at the, this is the CPU temperature, and this is the GPU temperature, which of course is technically on the same die, but it's a different partition on the silicon. So we look at those temperatures separately, but they're obviously cooled by the same thing. You know, it's all sitting underneath here. And one of the things I hope to do is put a I've got a couple of deeper fans which I'm hoping will fit in the case, so I can get some better performance on the CPU cooler. So let's take a look at some of the thing. Oops, that's the wrong keyboard. Let's move this keyboard back into the right spot and do this the right way. So by far and away, in my experience, the best tool to actually test whether overclocks are working or not is Unigine Heaven. So this is a benchmark you can download from the Unigine website. And the reason that this is a good benchmark to run is it's very sensitive to CPU and GPU overclocks. And it's quite a long benchmark. It takes about 4.5 minutes to get going. And it does work the CPU to some extent and the GPU. So if you've got an overclock which is unstable, this will either outright crash, which means you've really gone far too far, or you'll see artifacting in the rendering or quite significant stutters. Or the other thing to look out for, not so much on this one, but on superposition more so, is you need to actually do the run on like a stable unoverclocked system first and get a feel for what the frame timing is at the different scenes in the benchmark. You need to be familiar with that so you can see, for example, this is the important thing, something that looks to be working, but actually in some scenes the frame rate is diving off a cliff, because although you may end the benchmark with a run that says it was faster, you may have some scenes that are tanking, and that means that you're too near the edge. You need to back things off a bit. So this is the benchmark that I use. Let's see if I missed any comments here. So we're still talking about DMZs. Okay, right. Okay, everyone's commenting on sounds like Luke's past amazing beard. So given that this is the APU, I don't have to test this too vigorously. So what I've done here is I've been using 1080p low, and in fact for the purposes of this demonstration we'll just knock the resolution back to 720p. So what I will do is put that here, and I think I've got this installed. No, I don't. Okay, so let's just go and put the wrong mice away. Put the wrong mice away. This is the only problem with having all of these things. Let's do this. So well, so I also install P-Sensor. And I'm not going to demonstrate this because it's a bit too much to get on this captured screen, but I'll show you P-Sensor very quickly. This is P-Sensor here. Leave that mouse alone. I keep grabbing the wrong mouse. And what you can do is configure the hardware components that you want to track, like the temperature or performance of, and it will plot these. And I tend to have these up and running whilst the benchmark is running to keep a more accurate view on the temperatures and what have you. And the other thing which is quite handy, I don't know if you've seen this before, I've definitely had it on, is it CPU-X? CPU-X. Oh, it's installed. Okay. There we go. This is kind of useful. So this is a bit like CPU-Z on yeah, indeed. A bit like CPU-Z, isn't it, on Windows? So you can see some of the attributes of the processor, including things like voltages and temperatures and core speeds. And what this is useful for also is it has a version of prime number generation. So when you've got what you think is your overclock dialed in, I use this to make sure that the CPU can complete several runs of prime number generation without locking up the machine. But it also serves as a means to actually check the you know, the hardware status, particularly the voltage under load, whether the overclocks are going up to the appropriate frequencies, and the temperature again, which I do have displayed up here. So this is quite a useful utility. Now, in order to keep things simple, we'll get that off the screen. So we'll just use this as an example, and we'll just hit run, and that will fire up the benchmarking tool. You don't need to run it full screen, but the actual benchmark, you have to click this button here, and then it will actually go off and run. And you can see, you know, how many frames a second it's rendering out. And considering this is an APU, 720p low, that's a reasonable sort of set of, what's the word, options for an APU. But it's able to pump this out, well, at this moment, it's averaging 150 FPS, something like that. So quite reasonable. This is an older benchmark. It's not too demanding. I think it was geared towards DirectX 11. Obviously on Linux it's OpenGL, so the performance characteristics are quite different. But I would let this run. And if this gets to the end, I'd be fairly satisfied that that's a stable overclock, and then I'd go back into the BIOS, tweak some things, either undervolt a bit more if that's what I'm working on, or try and push up the memory overclocks a bit higher if that's what I'm working on, in order to you know, maximize the performance. So I find that Heaven is a great place to start to sort of validate whether your overclocks are okay. When you get too close to the edge, back it off a bit. When you're happy that this is able to run through those benchmarks, then I move on to a different benchmark, which I'll just bring up. In fact, I won't run it. It's Unigen's Superposition, which is very much a more GPU orientated benchmark. And again, I do that because that benchmark shows if you've got too close, it may run to completion, but it will, the performance will drop off a cliff quite considerably. So you can see if you've gone too far because it will actually slow down. So I used that, and then, as I mentioned, do the prime number generation, because that will really drive the CPU quite hard, and you'll be certain that it's working correctly. So I think what I'll do is I'll switch back to this screen, and I'll just move that keyboard to one side and that mouse out of the way. So I collected up some numbers whilst I was tuning this box. Let me just find it. I'm just opening up my notes over here. Okay, so I think that is what we need. If I just resize that. So let's just do this. So these were some of the notes I made about this machine. So when I started, I was doing 1080p low in Heaven, 1080p low in Valley, which is another Unigen benchmark, and then 1080p medium for superposition. So we can see here that the average frame rate was 61 for Heaven, 43.8 for Valley, and 16.7 for superposition. And after the overclocks that I showed earlier in the undervolting, that got to Heaven was able to complete in 83.3 frames per second, Valley up to 60.3, and superposition up to 23.25. And these are the respective percentage uplifts in performance. So we're looking at, you know, approximately a 30% performance uplift by overclocking the GPU. That doesn't have so much impact. That makes up like the last few percent. The biggest gains come from that memory overclocking. Hello Eurobertix, welcome to the stream, welcome back. So absolutely worth doing. Now you may be wondering, why bother doing this if I'm going to put a discrete GPU in the case? Well, specifically those memory overclocks, they will have an impact on the performance of games when running on a discrete GPU. Memory bandwidth can be a significant bottleneck for some games these days. Now these benchmarks down here are with the RX 580 and the 5700 XT, and as we can see, we get quite a significant step up in performance as we move to these cards. These were single runs, these aren't averaged. And this was where I was like, oh, I'm definitely going to want to get a discrete GPU in here because it can comfortably run everything at, you know, significantly higher frame rates. And then down here are some of my notes about going through some of the steppings as I was working through the process. So this was where I was changing the memory speeds and the GPU speeds and changing the voltages, and then just doing quick runs to check how the performance was comparing. I did briefly overclock the CPU to 3.7 gigahertz. The problem with doing that is you use sort of the dynamic frequency. It kind of locks everything at 3.7, which means you're constantly running hotter. And with all of those changes in place, I found that this cooler can keep the CPU at about 56 degrees Celsius, even when it's under load. So Medema says, if you have more thermal headroom, would you want to overclock the CPU higher? No. So I was saying earlier that I really don't want to introduce anything that's going to create more heat or utilize more power. This system is going to go in a very small case, which we will see, I don't know, maybe Friday. If not Friday, maybe Monday next week. Hopefully it will have arrived by then. It's a very small case, very little airflow. I want to maximize performance but not introduce any additional heat that I need to deal with in that case, if at all possible. So I've deliberately steered away from messing with OCing the CPU. The gains are not so great. And, you know, I'm using an APU. You know, if I really wanted to have better performance, I'd be using something like a 5600 or a 5600X as the CPU. That would sort of be the sweet spot for games performance. This APU loses a bit of ground to its non-APU counterparts. So although this 4750 is most similar to a 3700, it probably performs, due to the reduced cache, because it has an APU on board, probably performs more like a 3600. So I'm making compromises on the performance, but it's like, what performance is acceptable? And I think that this is going to be a very decent gaming machine when it's all put together. So hopefully that explains what's going on. Yes, yeah, that's right. So King Egypt points out I'm using the 47G because it was actually in this motherboard. I thought I'd got the 5900X in here, but when I looked, the 4700G was in there, which I'd been using on the test bench a few months ago. And I've got the 2400G and I think the 3600G, if that's right. So I've got different APUs. This is the best APU of the bunch. And one of the things I was considering is this. This is currently connected out of the back on the main board here with HDMI. And what I need to experiment with is, when it's got a discrete GPU, if you move the HDMI connection from the discrete GPU to the main board, it will dynamically switch, which is nice. But what if I can do it with both? What if I can have the discrete GPU and the APU available? It would be nice. I don't know if this is possible at all. I don't know if the discrete GPU will output through the main board HDMI. I haven't investigated this, but let's imagine that works. I could configure the games on this console that are not demanding to use the APU rather than the discrete GPU. So when we're playing something simple like Tokitori, we can just use the APU and save ourselves the whole hassle of the discrete GPU burning up some heat and power unnecessarily. So I don't know if that's going to be possible. I haven't investigated that, but if it is, that could be rather nifty. The other good thing is that if at any point in the future I want to change the discrete GPU, whilst I'm selling a GPU to pay for a different GPU, this thing can continue to function, albeit in a reduced, state by using the APU. So, I kind of like this, trying to find a way to make better use of this APU. And Tommy Luco says, am I looking at GPU pass-through? No, not on this at all. This is going to be a games console. It's not going to be a tinker box. Once this is set up and running, it will be something that my daughter can turn on, pick up a controller, play games on, and at no point does she have to ask me, can we play computer games today? Which is what the current situation is, because if my workstation is busy doing stuff, then the answer is no, we can't. And so the whole point of making this is it's a games console. You can just turn it on and play. So there's not going to be anything clever about it. GPU pass-through on the workstation at home is a thing now, because I've got two GPUs. I've got the 6900 as the main GPU, and I've got an NVIDIA T600 in there just for light CUDA workloads and NVENC. But that could be passed through entirely to another virtualized operating system if I wanted to. So that is on the cards for sure. It is. This is the problem I'm overcoming. It is solely my fault if my daughter can't play computer games. This is true. And the last 2 weekends, we did this weekend, we played some Lego Worlds this weekend, but the weekend before and the weekend before that we couldn't, because the Threadripper system, my workstation at home, was overheating, and I had to pull out all of the water cooling and go for a fully air-cooled system in order to get the thermals under control. And whilst that was in bits, she wasn't able to play computer games at all. So yeah, this is solving that problem. So I think that kind of outlines like what I've done here. This is going to be the platform B550 with a 4750G, and at some point this de-shrouded 5700 XT will go in as the discrete GPU, and should, I say with my fingers crossed, should fit in the small case now that I've de-shrouded it, and we'll find out whether I've got my sums right or not at some point in the future on that one. So McPhail says, is my daughter old enough to play the Streets of Rogue? I think I've... Oh no, I don't know if I've got that. It's a great family game, bit gory for youngsters. Possibly. I mean, she's into Japanese animations these days, and they're a bit more grown up than the stuff that she watched in recent years. So maybe I'll have to investigate. She's mostly playing Lego Worlds, Spyro, and something else. Can't remember what the something else is. So the games that she's playing aren't particularly gory at all. I've not introduced her to first-person shooters, mostly because I don't like them myself. We've played some racing games as well in the past. But yeah, I want to use this as an opportunity to introduce some other good games. Oh, and you know, we play puzzle games, stuff like that, quite a lot. What's this? Noob of the Linux. Yes, so you've gone for a noob of the Linux because you've been using Linux for over 25 years. I approve. Nicely done. So I think that outlines my plans. I don't know that there's anything else here that I wanted to demo today, because it's basically like it's ready to be used at this point. I need for the case to arrive before I can before I can push on in any meaningful way with the rest of these bits and pieces. But for those of you that are also enthusiastic PC builders and what have you, always interested to learn from your experiences and mistakes, so that I don't have to. Although I do worry that I'm going to be making plenty. Quite concerned about the build in the Node 202. It's very small, and I imagine it's going to be extremely frustrating. So Eurobertic says, I was a bit late to the party using Linux since 97-98. I'll tell you, for those of you that hear, just jam in the year that you started using Linux. I'll go as well. I'm not certain, but I think it was definitely by 1995. I think it may have been 94, but it was definitely by 95. 2006, 2009. Okay. 97. So there's some wise old heads here in the group here. 2006, 2010, okay. 97, yeah, Red Hat before it got confusing. That's musical coder, yeah. I had quite an exotic system. We had a cast-off Super Spark 20 workstation at work, and I got that as my desk workstation, and I had Red Hat running on that because it was, I think, the only distro I could find that supported Spark CPUs. But that was pretty cool. I gave it a go. So 2000. Yeah, okay. So quite long-lived. Nobody very recently, it looks like. Everyone over a decade, comfortably over a decade. Interesting stuff. Right, let's see now. Who's doing interesting things today? I don't know who this is, so let's go and find out. That's my philosophy on this one. Assuming it's, I hope it's English. We're going to go to this one because it sounds like they had a... Oh, they're not streaming anymore. This... Don't show me people that are not streaming then. Oh no. They are streaming, so if I click that... What? Twitch, behave yourself. Okay. I'm just a bit confused what Twitch is showing me here. Man, okay, right then we're gonna do this thing. We're gonna go here because I feel sympathetic to the title of this particular stream. So let's do that. Okay. So we're going to go and raid somebody called Adam Elmore. And we're going to raid them because they're hoping that their GPU doesn't melt today, just as mine did a few days ago. So I'll see you hopefully on Friday, and we'll see what new things have turned up by then. So stay safe, stay hydrated, and I look forward to speaking to you all soon. Thank you all very much for coming. Bye bye for now.